that we do and how we enable developers. So, a lot of people are familiar with Google from the consumer perspective, very used to using products and services such as Search, Android, Maps, Gmail, YouTube, Chrome, all kinds of different products that Google creates and provides out in the consumer space. And our mission through creating all these products and services is to organize the world's information and make it universally accessible and useful. And the most common, is Google search. This is kind of where we started. The text box that everybody is familiar with. You go to Google, you put in your query, whatever you're looking for, and usually a couple hundred milliseconds after you submit your query, you're returned with hundreds of thousands and sometimes millions of results. What a lot of people don't always think about is what is actually happening in the background when you submit one of these queries. There's an incredible amount of processing, of infrastructure, of networking, of operations, of code, of everything running in the background to make that simple little query happen. And we do this millions and millions of times a day for billions of people around the world. And through all this, we have built, a suite of technologies and tools that help our developers be productive and create these products that are reliable, they're scalable, and they iterate very quickly. So from a developer's perspective, we are able to roll out new versions and change minor things in our code with pretty much no interruption. We're able to do it very, very, very quickly. To kind of put it in perspective, what we've done, what we've built at Google is a really impressive set of technologies. And what Google Cloud does is takes a lot of those technologies that enable our developers within Google and provides it to the market for consumption for other developers, other IT operators, and anybody in the world to get access to. So this is what we call our developers cheat sheet. And this is basically every service. Oh, my power just went out. Sorry, can you guys still see my screen?
Yes, we can.
Okay. I don't know what's going to happen in the next few seconds. My power just blinked. But anyways, where'd that presentation go? Okay. So developer cheat sheet. This goes through basically all of the products and services that we offer on GCP and describes each of them in 4 words. So it's relatable for developers to understand what each of these services does. And as you can see, there's a really impressive number of these. So when you're going to build something, it might not always be obvious the tools that you need to leverage. And we break all these down into 3 main pillars. So the one that I specialize in is called infrastructure modernization. So this is basically looking at what IT shops are running today, typically in their own data centers, and helping them to modernize that into a cloud-native platform. We do this through a bunch of technologies like migrating virtual machines, from an on-premise data center into the cloud, and enable it with a whole bunch of tools, migration tools that we've developed to move either workloads or databases to a more cloud-native environment. There's application development, which is more Ahmed's specialty. So this really focuses on enabling developers to develop more quickly and more reliably with advanced tools that you might not have access to if you weren't using a cloud environment. And then there's data management and analytics, which includes artificial intelligence and machine learning. This is really Google's, one of our big strengths, where we, as most people are familiar with in our consumer products, we've developed things like Vision AI, which is the back end for things like Google Lens. So on your phone, you can pick up your camera, install the Google Lens app, and just point it around the room, and it's able to pick up and identify what objects are just by a machine learning model that does object recognition, right? So these are some of the things that we've worked on internally that we're now democratizing and making available to the general market. And one of our big differentiators when you look at Google compared to some of the other hyperscalers like Amazon and Microsoft is our network is very, very extensive. We have one of the largest privately owned fiber networks in the world. And by some measures, we carry up to 40% of daily internet traffic over our backbone. What this means is when you're developing applications and you're running applications on Google Cloud, you're able to leverage the power of our network for performance, as well as for privacy and security and reliability. So we make sure that when you're running your application, it gets to your consumers in a secure and low latency manner. And some of these things you can see on the screen here are our data center locations. So the outer circles are where our data centers are. So we do have one Canadian region today. So we have a region in Montreal, and then we do have a region coming in Toronto. Every Google Cloud Platform region consists of 3 zones. So each zone has its own power, cooling, network, facilities, fire suppression, all of these things that are totally separate from the other. So that means if we had a situation like what happened with OVH Cloud a couple of weeks ago, and we were to lose one data center, that region would still have 2 other zones fully up and operational without you having to actually do a disaster recovery failover to another geographic region. And we as Google are one of the, if not the largest purchaser of renewable energy. So as of last year, as of 2020, we have basically offset all of our previous greenhouse gas emissions through the purchase of carbon credits. So we've eliminated our carbon legacy. Every bit of carbon emissions that we've created since Google's inception in 1998 has been offset by purchasing of carbon credits. And our really ambitious goal is that by 2030, we intend to be operating on carbon-free energy 24/7. So as of today, we do invest very, very heavily in renewable energy. But as you can imagine, if you're talking about solar power, obviously you can't run 24/7 on solar power because you can only generate that while the sun is shining. Our goal is that by 2030, we're going to have enough diverse sources of renewable energy. We'll be able to run 24/7 on carbon-free energy. So now I'm going to pass it over to Ahmed to talk a little bit about developing on Google Cloud.
Thanks, Matt. Can you? Yeah, I will need your help to move for the slides.
Yep.
Or I can share my screen.
My power just went out again, so
I'll share my screen. Yeah, I'll share my screen.
Okay.
So just to let you know, guys, some of our attendees have lost their power as well.
Okay.
The session is being recorded, so we may want to take that into consideration.
Mostly Halifax people losing connectivity?
Yeah, mostly Halifax. I'm based out of Montreal, and I'm good.
Okay, so my turn's coming soon, I suppose.
Yeah. So, I think within like every IT shop, there are like 3 different bubbles, and like to kind of have a mental model of how GCP brings value. The first one is business. The business needs more innovation and needs to be flexible. Developers need more consistency and speed. We want to ship software more often, and like just do it consistently. And for operators, which are like our DevOps teams, or they need control and more automation. So with that in mind, like when we think about our offerings in terms of app modernization, we usually think about how we can enable, how we can remove the infrastructure management from the teams, like to do it, and offer it as a managed product. We enable composable architecture, integrated login and monitoring for everything, like one single pane of glass. We help manage security and pay only for what the application uses. So you can see here kind of like how the products work together in order to enable that vision. The idea here is like even just for compute, we have different products. You can start with Compute Engine, which is like just a VM running on Google Cloud infrastructure. The second abstraction we offer is Kubernetes. Kubernetes is a container orchestrator. If you have your applications running in containers, you need to run them in like with the container orchestrator that will monitor the health, make sure that the applications are running, manage all the resources, whether it's compute, networking, or storage. So we do have a managed offering for Kubernetes called GKE. The third abstraction is more around Cloud Run, where it's all serverless. You have an application, you just want to expose it as a service, and that's what exactly you care about. You don't need to think about, I need a cluster, I need to provision resources, I need to maintain that cluster for like the next 3 or 5 years. With Cloud Run, you only think about the service you expose. I have a business logic, I need it to be exposed. That's what I need that's exactly what I need to care about. App Engine is more suitable for web applications, and Cloud Function is everything that will answer an event. Something happens, I need this function to run. This function will finish running, and it will expose and it will output something. So this is exactly the use case of Cloud Function. And you can see that like the more we go to the left, the more I have kind of infrastructure to manage, and the more we go to the right, it's completely serverless. We released, I think a couple of weeks ago, something that comes here in the middle, which is Kubernetes Autopilot. So the Kubernetes Autopilot offers exactly the same API as GKE, but you have an abstraction around the VMs or the servers that your Kubernetes cluster is running. So we provision them automatically, we destroy them automatically, and you only pay for the resources consumed by the pods running on the cluster. And feel free to interrupt me if you have questions. I'll be more than happy to help. And we kind of like we're able to do that because we have like over a decade of innovation that we carry, right? Like in 2003, we built our internal Kubernetes container manager, which is called Borg. It's still used internally. Cloud Run fully managed actually runs on top of Borg, I guess. I need to double check. After that, we've seen the birth of Docker, and like since Docker was created, we've seen Kubernetes, and the rest is kind of history. So when we think about app modernizations, there are 4 personas that we usually encounter. And so if you want to, it gives you like just a mental model if which part of the stack you would like to contribute to. Even if you are a developer, you might be working not as an app dev, building the business logic. You might be working as a service operator, where you're doing more SRE work than building the business logic or the applications themselves. The third persona we see is platform admin. So the platform's admin are people that will write Terraform code, will make the infrastructure, will create the infrastructure, will maintain the infrastructure, and the app platform and app and platform security are people who will more write policies, think about how we secure our environments, how we do access APIs. Like those are the 4 areas we see in terms of app modernization. And you can be doing everything, but usually when we try to build the concepts, we always have in mind those 4 personas. Okay, so if you are building a new software, or you are taking your old software and modernizing it, you always need to think about how you can automate everything. Usually when I start developing an application, I would first start by writing my automation code. So you see here, the first thing is I create my build, how I want the application to be built. And this is what we call a pipeline, like through a CI/CD. I think the most known tool for CI/CD is Jenkins. We do offer Cloud Build. We interconnect with all the CI/CD tools, but our fully managed tool is Cloud Build. And after that, once I have that code, I put it into my code repository, and we have Cloud Code. It's just a Git interface, like to push code to. After that, once the pipeline runs, it creates artifacts. We can sort those artifacts into the artifact registry. And once I have my artifact and I need to deploy that artifact as a service, I have a choice between Cloud Run, GKE, App Engine, Cloud Functions, and we talked about this before. Once it's deployed, I need to start monitoring my application. I need to get access to login. I need to get notified if something happens. So this is the operation part of the house. We use cloud monitoring, cloud login to access login and monitoring KPIs. So if you're a developer, I think you would most likely enjoy the built-in features. It's kind of exact same thing as VS Code. If you use VS Code locally, you have VS Code integration into the shell itself. So once you log into GCP, you can access. You just start your cloud code into GCP itself. You don't need to have anything installed locally. So the platform itself allow you to do scheduling of resources, lifecycle and health management, scaling up and down, naming and discovery. So once you have a couple of applications, you want those applications to know or discover themselves. Load balancing, storage volume, login monitoring, debugging, and introspection and identity and authorization. So all of this is offered just with GKE. In terms of security, we built tools to secure the application, like all this, the delivery chain of the application is secured. You can, once you have your artifact, those artifacts can be scanned for vulnerabilities within the Google Container Registry. And once the artifact or the container starts running on a GKE cluster, there is also what we call binary authorization to make sure that we're actually deploying the right artifact. And once it runs, again, we do have other vulnerability or scanning tools that enable you to make sure that you're not running something that is vulnerable on your clusters. Operations, here we're looking at what Istio offers. Like we have an offering called NTOS Service Mesh, and it's just a managed service of Istio. You can see that you can have a uniform observability across like all the clusters that run for all applications that you're hosting. And in terms of like all of this, like is all of this is built like to have one single umbrella called NTOS, and NTOS is just a collection of the tools that we've seen. At the bottom, we have orchestrators using Kubernetes. Once we have this Kubernetes, we need a network layer. That network